All right, going to run through the solutions for this. That looks like pretty easy calculus here. Antiderivative of that is x to the fourth minus x squared over 2 from 1 to 2. 2 to the fourth is 16. 2 squared over 2 is 2 minus 1 minus a half. That looks like 14 minus a half, which is that. I definitely don't want to spend more time than I need to on easy questions. Let this function be defined by blah. Which of the following values do we have a local minimum? Okay, so I need to find the derivative, and the local minimum is where f prime goes from negative to positive. Okay, so f prime is equal to 3x squared minus 6x minus 9. This is no calculator, so I'm going to have to factor this. 3 times x squared minus 2x minus 3. That's 3 times x minus 3 times x plus 1. Sometimes you have to do algebra. And so I'm going to have, that's a 3 and a negative 1 here. This is just an upward opening parabola. You can test numbers if you want to, but it's going to go positive, negative, positive. So f prime goes from negative to positive at x equals 3. Number 3, at the derivative of this mess, that looks like a bunch of chain rule kind of stuff. I'm just going to rewrite it as 2 times the sine of x to the 1/2 squared. I like that better. At least they didn't put the little sine squared in there. They could have done that, because that would be correct notation for that. Okay, so little Russian dolls, right? So the derivative of something squared is just 2 times that thing to the first, and there's already a 2 out there, so that's going to be 4 times the sine of x to the 1/2 to the first power times the derivative of what's inside. Derivative of sine of whatever is cosine of whatever times the derivative of what's inside that. Okay, so looks like that's what we got. I think I'm feeling this answer right here. I had 4 times 1/2, so the coefficient is going to be 2, not 4. And then I've got sine of x to the 1/2 times cosine of x to the 1/2, and then I've got the x to the negative 1/2 there. So that looks good. Number 3 is D. The position of particle is given by the parametric equations. These are position equations. What is the velocity vector at time t equals 1? That should be easy. So the velocity in the x direction is the 1 over t squared plus 1 times the derivative of what's inside. And you think it's going to be a lot of chain rule? Oh yeah, every time. And then here, derivative of e to the whatever is just e to the whatever times the derivative of what's inside, which is just negative 1 for that. And at time 1, when we plug 1 in, I get that's equal to 1 is equal to 1. Sorry for the messiness there. Vx of 1. Vy of 1 is equal to negative e squared. So 1 comma negative e squared is answer choice B. Number 5, sum from 1 equals n equals 1 to, you know what 1 equals? Equals 1. N equals 1 to infinity. This is, okay, so what kind of series is this? This is a geometric series. I hope that you recognize that. If you're actually asked to find the sum of a series, it's got to be geometric, or you have to be able to match it up to a series that we know, like the series for the e to the x or cosine or sine or something like that. So question is the multiplier of this series less than 1? And the answer is yes, it is, because e is about 2 and change and pi is 3 and change. So the terms of this series, the first one, when you plug 1 in, is e to the pi, and then e squared over pi squared, and then so on and so on. So the first term is that over 1. This is sum of a geometric series' first term over 1 minus r. Section 10.3. 1 minus the multiplier is also e over pi. And then they just cleaned that up. So if I multiply the top and bottom by pi, that would give me e on the top, and then on the bottom pi minus e. That looks like that. All right. Table above gives the values of twice differentiable functions. All this twice differentiable stuff just means you can assume everything's nice and smooth, and you can do all the things you want to be able to do. And their derivatives at x equals 2. If h is the function defined by this, what's h prime of 2? Quotient rule. So h prime of x is equal to low d high minus high d low over low low. And now I just have to carefully plug in. It's only 2 that I'm plugging in, so I think I'm just going to go straight to that. So g of 2 is negative 2 times f double prime of 2 is 3. F prime is negative 3. G prime is 5. And G is negative 2. Let's see if I did that error-free. So that's negative 6 plus 15 over 4. 9/4. Well, the answer's there, and it's the right one. Number 7. Which of the following is the Maclaurin series for this? Well, the series for cosine is even. Definitely not going to need more than 3 terms to diagnose which is the correct answer. None of them have even the same 2 first terms, so just that probably will be enough. And then if I plug in x squared into that, that's 1 minus x to the 4th over 2 factorial plus x to the 8 over 4 factorial, sorry. And if I multiply by x, then I get x minus x to the 5th over 2 factorial plus x to the 9th over 4 factorial, and so on. Geez, I hope that's there. Oh yeah, it is. There it is. Answer choice A. Got to know your big 4. You got to know the series for sine x, cosine x, e to the x, and then your sort of generic geometric series. Right, first term's 1, multipliers x. Those are the ones you should definitely know. Here, I am a student in BC Calculus, and I see a limit question. It's either going to be definition of derivative, or it's going to be L'Hopital's rule. Probably L'Hopital's more likely. So I just got to check here. If I plug infinity in, is this infinity over infinity? Yep. So I can do L'Hopital. So let's see. That's going to be minus 12x on the top, and then on the bottom it's going to be 3e to the x. And then if I L'Hopital, that's still infinity over infinity. I think I see where this is going. If I L'Hopital one more time, then the top is just going to be negative 12, and the bottom is still blowing up, so that's going to go to 0. Which is B. Number 9. Function f is not differentiable at x equals 5. What does that mean? It could mean different things. It could be not differentiable because it has a sharp corner. It could be not differentiable because just for like the tiniest instant, like the cube root function, it gets vertical. And it could be not differentiable because it's not even continuous. It could be not differentiable because, you know, there's a jump or something like that. So what has to be true? Does this have to be true? No, it could be continuous. It could be one of these, right? These are continuous but still not differentiable. So the limit as x approaches 5 of f of x does not exist. It does if it's continuous. The limit as x approaches 5, well, this is the definition of the derivative. So if this did exist, that would be the derivative. So that has to be true. If it's not differentiable at 5, then that can't exist because that's the same thing. And then does it have to be true that this integral does not exist? Now, that in all three of these cases, that does exist. So looking at answer choice C there. Definition of the derivative. Number 10. That'll be the last one for this video. Second derivative of a function f is given by f double prime is equal to this. At which of the following values does x have a point of inflection? They like doing this thing where you get sign changes at some of these and not sign changes at others. Because this is the same question as what's the definition of an inflection point? An inflection point is not where these things are, where the second derivative equals 0. It could be, but the actual definition of an inflection point is sign change of the second derivative. So we need to have a sign change. It will change signs here, right? From negative to positive. If you want to check some values there, you can do that. And it will change sign here. But it will not change sign here. Did I get those signs right? This is the right sign changes. It is this answer. Let me just make sure I got these things right. I have a feeling that I didn't. Let's see. So if I plug in like a very negative number, then this is negative, and this is negative, but this is positive. Yeah, so that's that. And then if I plug in a number like 1, that's 1 is positive, this would be negative, and this is always positive, so that's negative. And then if I plug in something like, I don't know, 6, then this is positive, this is positive, this is positive, and then if I plug in something way up there, then that's also positive. So I still get the changes, the number of changes in the spots the same, but that's fixed now. All right, so it goes concave up, concave down, concave up, concave up.